In this video, we're going to look at how to determine if two functions are inverse functions. The specific functions that we have are f of x equals 1 over 2x and g of x equals negative 1 over 2x. Now, if you're given two functions and you need to determine if they are in fact inverse functions of each other, the way to do that is to evaluate the f of g of x and the g of f of x. We have to evaluate both of these, and if we get x for both of our answers, then we know, in other words, once you plug one function into the other and do algebra, if it simplifies to x in both of these situations, then you know that they are inverse functions. If that's not the case, though, they are not. So first of all, let's figure out what the f of g of x is. So f of x is 1 over 2 times x, so the f of g of x would be 1 over 2 times whatever g is. And g is negative 1 over 2x. So we just put the g function, negative 1 over 2x, in the place of x. That's all we did, right here. And now we want to simplify as much as we can, so we can't do anything in the numerator just yet, but the 2 times the 1 over 2x, essentially those 2's are going to cross each other out. And we're going to be left with negative 1 over x in the denominator. And now what we can do is we can rewrite this. In the numerator we have 1, we can rewrite that as 1 over 1. And we're dividing fractions, so we can multiply by the reciprocal of the denominator. And so we're going to have negative x as our answer. Now automatically we didn't get x, and we have to get x as our answer if these are going to be inverse functions. So at this point we could actually stop and say that these are not inverse functions. But just to show you the other direction, the g of f of x, I'm going to work that out also. But again, if you already work out one of them and it doesn't equal x, you can stop at that point. So evaluating the g of f of x is just putting f of x inside of g. So g is negative 1 over 2 times something, and that something is going to be our f of x, 1 over 2x. And in this case, again, the 2's are going to cancel in the denominator, and we're going to be left with negative 1 over 1 over x, and again, we know what that's going to simplify to. It's going to equal negative x for the exact same reason as the problem above it did. And so we got negative x in each case. So it's really close to being inverse functions, but it's not quite there. So these are not inverse functions. If we'd gotten positive x in both cases, then they would be. So not inverses of each other. And that's it. That's all you have to do.